Okay, so starting from the introduction, you can see the image in which we can see different context. The question here is this thermal comfort same for all the people? For example, if the person who is in the right is given the context of the person who is in the left at the same temperature, will they be feeling the same comfort level? So to answer this question, there are a lot of answers, but looking at ASHRAE, which is widely accepted and also is making the standards for thermal comfort. So what they say about it is thermal comfort is the condition of mind that expresses satisfaction with the thermal environment and is assessed by subjective evaluation. So important here is that it varies from people to people as it's a condition of mind, but at the same time there are factors which can be used to assess, which I will be discussing later. And then if we go back to the history, why thermal comfort or became so important and when it became so important. So it goes back to early decades of the 20th century after the World War, when it was used to resolve the particular problems due to stressful situations in the workplace. So Fanger and other researchers marked the study as a real discipline, and they felt so much importance of this thermal comfort. So for the thermal comfort factors, basically, which can help us maybe to assess and which can also help us in designing as well. So although it's different from person to person with respect to ASHRAE definition as well, but at the same time there are factors which trigger this thermal comfort, which includes clothing insulation, for example, the R value of the clothing, humidity, air speed, air temperature, then radiant temperature. The example of the radiant temperature will be maybe the laptop. A person can feel more warmer because of the laptop. That is so much local to the place. And then metabolic rate, what type of activity the person is doing. So yeah. And then if we look at the thermal comfort in the occupant behavior, the main research is done on the performance, how performance declines with the low level of thermal comfort. So even if there's a lot of difference in warm temperatures and cooler temperatures, if you look at the performance, so in warmer temperatures, the performance is 2% more lesser than it is in the cooler temperatures. So, and then if we look at energy use and the thermal comfort, the idea here is to give a global overview of where are we using our energy, especially in the building sectors. So we can see, which have highlighted here, water heating, ventilation, cooling, and heating. So mostly our energy is going into making thermal comfort spaces. And then if you look at, sorry, yeah, this one. So at the same time, we are talking about the building sector, which is utilizing a lot of energy to keep balance in the thermal comfort. But at the same time, there's inefficient use of this in buildings. The factors may be impacting is bad design, wrong calculations of HVAC, etc. And I think this is the situation which all of us have felt at some place. And then like in bigger rooms or bigger offices, a person who is sitting away from the air conditioning system is maybe feeling more hotter than the person who is just sitting below the air conditioning system. So maybe these are the things which can be optimized. So the possible solutions are getting into the detail analysis in our designs, then simulation of workspace environment before the building is constructed, and then having the right knowledge of HVAC systems